Okay, in this video I'm going to continue on with exercise 2b of the book Fundamental Applied Mathematics. We're on page number, what page are we on? We're page number 48, and we're going to do question 4. So question 4 states, a car accelerates from rest to a speed of 20 meters per second over 5 seconds. It then continues at the constant speed, and you're to calculate the usual things. And then it says the total time taken given the total distance was a quarter of a kilometre. So we're told the final distance. And right, look, you don't really need to read all the questions because you know what you're going to be asked for. So the first thing we're going to do is we're going to sketch what's going on first. So we draw our y-axis, we draw our x-axis. On the x we have time measured in seconds, on the y we have speed measured in meters per second. Like that. So we know the car accelerates from rest. So that means at time t is equal to 0, the velocity is also equal to 0. So we draw that point. We know that over a period of 5 seconds, it accelerates to a speed of 20 meters per second. So well, let's say that's 20. So over 5 seconds it accelerates there. You can join them by a straight line because the acceleration is constant, and it continues at this constant speed. So we know that it continues where there is no acceleration at a constant speed thereafter. Once again, remember, if you have t1 and t2, where t1 is greater than t2, like this is after this. This could be 5 seconds, this could be 2. So in other words, yeah, they're after each other. And say the corresponding velocity v2 and v1. So if at a later time the velocity is greater, that means the acceleration is positive. If at a greater time the velocity is, or the speed is less, that means it's negative. It's a negative acceleration or deceleration. And where the velocity is equal, that means a is equal to 0 and there is no acceleration. Okay, so that's it's kind of intuitive. You should understand these things just by you see them pretty much every day. So we're asked to calculate the acceleration. So how to go about doing this? Well, I suppose the easiest way is to get the acceleration. Let's see if I can help you with this. Right, what I'll do is, there are two ways of doing this. The first one is the normal you've asked, like that. Okay, so we know that the initial velocity is 0, the final is 20, the acceleration is unknown, the distance is unknown, and the time is 5 seconds. So let's try v is equal to u plus at. In this case, the only unknown is the acceleration, this one here, and since there's only one quantity, then we're okay. So 20 is equal to 0 plus 5a, therefore we can say a is equal to 4 meters per second squared. Like that. Now, that's pretty straightforward. So will we just get the, sorry, I put that in the wrong place. 4 like that. Now, that's pretty straightforward. We'll get the distance just because we can. So s is equal to u plus v over 2 times t is equal to 20 over 2 times 5 is equal to 10 times 5 is equal to 50 meters. Like that, and the area is 50 meters. So remember, the distance is also given by the area underneath the curve. So we'll ignore that for the moment. We'll ignore that it's given by the area underneath the curve for the moment, right? So I'm just going to get rid of this. I want to show you something else about how to calculate the acceleration. We know the acceleration is 4 meters per second squared. So let's just look at, we'll say, this triangle here on its own. It is a right angled triangle, and we know that if this is 0 and this is 5, the length of this side here is 5. It accelerates to a speed of 20 meters per second, so the length of this side is 20. If you were to graph it, of course. So we're going to call that angle theta and that angle alpha. Now, I think it's fair to say that we know a bit of trigonometry, especially having done a chapter on vectors, and we know, or should know, that we can describe sine, cosine, tan as follows. So we know that, for example, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what if we got tan theta? What we know, for example, that we have, if we're talking about theta, we have the opposite and the adjacent corresponding to tan. If we have the, if we're looking at alpha, we also have the opposite and adjacent corresponding to tan. So we can say tan theta is equal to opposite 20 over adjacent 5. So let's just get the inverse tan of that. Press shift tan for inverse, 20 divided by 5, and we get 75 degrees. That's 75 degrees. Right? Oh, I wrote 70, didn't I? Was it 70 or 75? One sec now. 75 degrees. Why did I write 70? So we know that theta here is equal to 70 degrees. What else do we know? Let's try the length of the acceleration. We go, that's a hypotenuse, so h squared is equal to 5 squared plus 20 squared. That's by Pythagoras. So that's equal to 5 squared plus 20 squared. So h squared is equal to 425. H is equal to the square root of 425. H is equal to 20.61. 20.61. Now, 20.61, and just let me think there for a moment, because we've gotten all the pieces. We just need to put this together. We need to get, oh yes, right, you didn't really need those, but let's try and think about this for a second. Yeah, I'm going to tell you that the acceleration actually corresponds to the slope of the line, of this line here, the slope of it. So how do you get the slope? Well, you could say to yourself, well, first of all, I'd say, what is the slope? The slope is the rate of change. So it's the change. Usually you'd say delta for change, say delta s, the change in distance, divided by time. That's what acceleration is. Well, but that's also what slope is. So we know that acceleration is the rate of change of speed with time. So, but we also know that a slope is a rate of change. So if we got the speed at here and the speed here and divided by the time, we should get the acceleration. But look, what's the formula for slope? We'll say m is equal to, what is it, like y1 minus y2 over x1 minus x2. Is that it? Yeah, that's it. And what's that? That is delta y over delta x. The change in the y over the change in the x. But look, what is acceleration is equal to, we'll say delta, the change in velocity or the change in speed over the change in time. Or you could say, actually let's make an easier one. Let's go for an easier one, one that we definitely know. We know that velocity or speed is equal to distance over time. It's equal, actually, the change in distance over the change in time. So the same thing here. You could say that the acceleration is delta v over delta t, like that. Now if this is getting a bit much for you, you've never seen this, that's okay, stick with the area method. I'm just saying that you can do this too. So it's a change, that's what a slope is, delta something over delta something. That's what a change is. So just bear with me now. Using the slope formula, you don't even need to know that it is the slope formula, you should be able to work it out. What's the speed? What's y2? The speed at y2 is 20. What's the speed at what's the speed at y1? It's equal to 0. What's the time at x2? 5. What's the time at x1? 0. So 20 over 5 is equal to 4. the slope equals 4. What did we get our acceleration at? 4 meters per second squared. So the slope corresponds to the acceleration. y2 minus y1 over x2 minus x1. I don't like learning formulas like that because it's kind of monotonous, and if you don't understand it, you'll never be able to use it. So it's the change in y over the change in x. That's all it is. That's what a slope is. The rate of change with something with respect to something else. So it's the rate of change of y with respect to x. And just to suggest something, if I'm assuming you're studying this now in 5th year, but when you go on to, let's say, towards the end of 5th year and definitely 6th year, you'll come across this differentiation. And what is differentiation? That works out your rate of change for you. It's a way of working out your slope, and you'll get things like dx dt, like that. That's your slope, and it'll do it for you automatically. So anyway, the point was, slope will get your acceleration also. But look, if that's over your head so far, then that's just fine. There's no big deal about that at all. And just let's see if we got the acceleration, we got the distance. We'll just get the distance very quickly here. The distance is the area of the triangle, so half times 5 times half the base by the perpendicular height. So that's equal to 50 meters there, like that. And the last part of the question says total time taken. You have to get the total time, which we did, was 5, wasn't it? Oh yeah, we're told that it continues at this certain speed up here like this up to a certain time. And after that certain time, the total distance covered is 1/4 of a kilometer, which is 1/4 of 1,000 meters, which is equal to 250 meters. So the total distance covered is 250. We know this here is 50, that means this is 200 meters. Now, let's work out the total time. We want to find out the time here. Well, that's just an area as well. You can say, what's the area of this? It's the base by the height. So it's the base times 20 is equal to 200. The base is equal to 200 over 20. The base is equal to 10. So this was 10 seconds. That's 10 seconds. That means this point here is 15 seconds. And let's check that out at the back of the book. 15, 50 and 4, and all those answers are correct. There you go. Now look, don't get bogged down in that slope method. That's just, I kind of threw that in there just to see how people would accept it. But look, don't mind about that. The other methods are all perfect. So look, thanks for watching. Please subscribe to my channel, pass it on to your friends.